Good morning, everybody. This is the first lecture for the Stars and Galaxies online class. In this lecture, I'm going to talk about where we located in the universe, how big is the universe. We'll talk about the cosmic calendar, and then we'll also talk about the light year and the astronomical unit, which are the the units if you measure the very long distance. So if you look the universe is extraordinarily large, and at the same time it is extraordinarily empty. On average, it is 10,000 times more empty than our galaxy. At, at you'll see later, even the galaxy is mostly empty space. The air we breathe has about 10 times 10 to the 19 10 times 10 to the power 19 atoms in each cubic centimeter, and we usually think air as an empty space. In the interstellar gas of the galaxy, there is about only one atom in every cubic centimeter. If you draw one centimeter cube, you will find only one atom. But here in the air, if you draw 1 centimeter cube, you'll find 10 times 10 19 atoms in that cube. Intergalactic space is filled so sparsely that in order to find one atom, you have to move or you have to search 1 cubic meter of space. This is unbelievably empty. That means the universe is mostly empty. So now, before we go into deep about the universe, let's talk about the Earth. The Earth is one of the planets in our solar system. The diameter of the Earth is 12,742 kilometers. So it is about roughly 13,000 kilometers, the diameter. That means if you move from one end to another end, the average diameter is about 12,742 kilometers. The solar system, which consists of the sun and the planets and their moon and the countless smaller objects, which includes asteroids and icy comets. The sun is a star, just like the other stars that we see in our night. In order to compare the dimension of the sun with the earth, the sun is about 109 times larger than the diameter of the earth. It's 109 times larger in diameter than the earth. The diameter of the entire solar system, when I say the solar system, that means the sun and the planets and the countless other tiny objects, is about 122 AU. The AU here stands for the astronomical unit, and the one astronomical unit means this much distance, which is 149 million kilometer about. So the one astronomical unit is the distance from the Earth to the Sun. Always remember, the one astronomical unit is the distance which is from Earth to the Sun, and it is about 150 million kilometer. Now we talked about the Earth, we talked about the Sun, we talked about the solar system. And if you go further on larger scale, we'll talk about the galaxy. The galaxy is an island of the stars. So whenever we talk about the galaxy cluster, that means it is a group of the galaxies. And each galaxy has millions of stars. The galaxy cluster, which is a group of galaxies, and again the supercluster is a large group of a smaller galaxy or the galaxy group. If we talk about the galaxies that we are in, Milky Way galaxy, it does have 54 the galaxies. The local group, the Milky Way is a part of the local group galaxy group, and it does have 54 the galaxies. The local group contains the galaxies including the Milky Way galaxy. And the supercluster is a large group of a smaller galaxy or the galaxy cluster. So if I put all the pictures, the Earth, Sun, solar system, galaxy, local group, local supercluster, this is showing the picture here. Let's start with the local supercluster. And if you see the scale here, just a tiny speck of this one is the local group, which contains many the galaxies here. And if I just pick out one, then this is the Milky Way galaxy. And on the Milky Way galaxy, this tiny portion here, this tiny dot represents the solar system. And on this solar system, this point represents the Earth. So if we start from the local supercluster, and if we compare the Earth, this is very, 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 very tiny. Very, very tiny. So in order to compare this distance, we either going to use the different kinds of scales. And I'll talk that later, which is called 1 to 10 billion ratio. And that comes later. The only thing I would like you to point here is let's take a look on the Milky Way galaxy. And on the Milky Way galaxy, the solar system just looks like a point, a dot. And if you take the solar system, the Earth, it's just like a point too. So that's how small the Earth is in comparison to the solar system or the galaxy. And the universe is a combination of all the supercluster group, Milky Way galaxy, the solar system. This is only one only one unit, and there are billions of local supercluster within the universe. So the universe is huge. And you see, just to compare the size, the Earth is just a nanospeck in comparison to the Milky Way galaxy or even to the solar system. What is a star? It's a large glowing ball of gas that generates heat and light through nuclear fusion. And we'll talk about the nuclear fusion process later on. And the planet is an object that orbits a star. So we have a star that that generates heat through nuclear fusion process, and any object that orbits a star is called a planet. For example, Earth is a planet of the solar system because it orbits around the sun, which is a star. And then we come to the moon. Then there are objects that also orbits around a planet. The object that orbits around the planet is called the moon. Earth has the moon, and other planet does have the moon too. Asteroid is is you can consider asteroid as a tiny planet because it also orbits around the planet, but it's very tiny, and the scientists do not call this is a planet. It's because it's a very small in structure. The one thing for those who are curious to know, the asteroid has a non-spherical shape. It's not in a sphere. It's some arbitrary structure, and the reason is it's tiny, and, and the gravity is not strong enough to compress the material into a sphere. That's why it can be of any other shape. But if it is large in size, then the gravity will also be strong enough to compress all the materials into a sphere. A solar system, as I mentioned before, includes the planets, the moons, asteroids, comets. And now the galaxy is an island of stars, and all the stars are held together by gravity, and it is orbiting about a common center. So the galaxy is made of all the stars, and the stars has the planets. Earth is one of the planet. And now if you look the universe is a combination, is sum total of all the matter and energy. The matter is all the galaxies, or you can call the galaxy cluster or supercluster. The dust particles, the dark energy, is everything you see is a part of the universe. Now let me give you a perspective of the distance in terms of light. The light has velocity, and it moves about 300,000 kilometers in 1 second. 300,000 kilometers. So it takes only 1 second for the light to reach to the moon, and it takes about 80 minutes to reach to the sun. So you see, if I just compare the distance between the moon and the sun is very far. You can just compare how far it is just by comparing the time. It just takes 1 second to reach to the moon, and it takes about 80 minutes. So the sun is very far. And now if I took the galaxy, let's say for example Andromeda galaxy, it is about 2.5 million years. This gives you a perspective how big the universe is. Okay, the light I mean, if we just travel to the moon by foot, you can calculate how many years it takes. And it takes 2.5 million years for the light to reach to the Andromeda galaxy. That's how big the universe is. Now, let me ask you a question. How far away we can see it? Okay, so this is an Andromeda galaxy, and this photo shows the Andromeda galaxy as it is looked back 2.5 million ago. So the light, because it takes about 2.5 million years for the light to travel from the galaxy to the Earth. So if you take a picture now, so that gives you the picture of 2.5 million years ago. Okay, so if you take a picture of the Andromeda galaxy, then that picture tells you the story about 2.5 million years ago. Now let me ask you a question. If something is happening right there in the Andromeda galaxy, when will you be able to see what it looks like now? Think about this one. Or I'll just give you the answer. So if something is happening in the Andromeda galaxy, you should be able to see about 2.5 million years from now, because light takes 2.5 million years to come from Andromeda galaxy to the Earth. What is the light year? The light year is not the unit for the time, although it says the year. Remember, it is the unit of the distance, and the distance a light can travel in 1 year. Why we're using the light year? Because the cosmos, the entire universe, the size of the galaxy, the size of the solar system, the distance between Earth and some other galaxy is so big, we cannot describe, or it is very inconvenient to describe in terms of the other numbers. So we're using light as a light year as a distance, because light can travel so many distance in 1 year, and it becomes a little bit more convenient to express the size of the galaxy or the distance between the galaxies in terms of the light year. So what is the light year? The light year is the distance light can travel in 1 year. If I ask you, what is the distance in kilometers that light can travel in 1 year? Let me do that. So the 1 light year, if you need to, is the distance. And you know, how do you calculate the distance? The distance is the velocity times the time. What is the speed of the light? This is 300,000 kilometer per second. And in 1 year, you calculate how many seconds you have. That gives you this number. This is the distance. This is the distance light travels in 1 meter, which is about 9, let's say 10 billion kilometer. Okay, the light travels 10 billion kilometer in 1 year. Can we see the entire universe? You see, we already covered that in order for the light to come from Andromeda galaxy to us, it takes about 2.5 million years. Okay, so there are many the galaxies. Let's say from this galaxy it takes about the 7 billion years. And if you look for other galaxies, the light has not come to the Earth yet. It is still on the way. It might take another billion years for the light to come. So we cannot see everything because the light from the other galaxies has not yet reached to us. It does not have enough time to reach to us. It will come sometimes later. So the maximum, what you call the observable universe, is 14 billion light years, and above that the light has not reached to the Earth yet. So I have a question for you. Why cannot we see a galaxy which is 15 billion light years away? And you know the answer. Looking 15 billion years away means looking into time before the universe existed. Just to keep you in mind, the life of the universe is between about 15 billion years, or in other words I can say it is between 10 billion to 16 billion years. If something, that's the age of the universe, so if something has existed, so what's the answer for this one is why we cannot see a galaxy that is 15 billion light years away. The answer is because looking 15 billion years away means looking at time before the universe existed. So where we located in the universe? So as I mentioned, we are a part of the solar system, which is a part of the Milky Way galaxy, and this is a member of the local group of galaxies in the supercluster. So the bigger picture we look is the supercluster, and then we have a local group of galaxies. Milky Way is a part of that, and then we have a solar system, and then a solar system we have a Earth, and even on the Earth we located the different parts of the world. How big is the Earth compared to our solar system? In order to, and now you can calculate everything in terms of kilometer. But now let me give you a perspective now. If I reduce the size of the solar system by 10 billion times smaller, 10 billion times smaller, then the sun becomes the size of a large grapefruit or watermelon, let's say. If the sun is the size of a watermelon or a grapefruit, 14 centimeter in diameter, then the earth would be just a ballpoint. That's how tiny earth is in comparison to our solar system. A ballpoint, just a tiny dot. You just mark a dot there. That's how small earth is in comparison to our solar system. And on the same scale now, so on the same scale 1 to 10 billion scale, if I reduce, the sun is the size, as I mentioned, the sun is the size of a large grapefruit, and the earth is the size of a ballpoint 15 meters away. So if we have a sun, and then if you keep the earth 15 meters away, a tiny dot, that's how small the earth looks like in comparison to the sun. So if I reduced everything to from 1 to 10 billion scale, that means everything is divided by 10 billions. Then the Pluto, which is not a planet anymore, would be just a few steps walk. And the Alpha Centauri would be the distance of the United States, which is 2,500 miles. If everything be shrunk down to, from 1 to 10 billion scale, then in order to reach to the Alpha Centauri, you have to walk 2,500 miles. Just 1 second, I need to, okay. So, as I mentioned, if we reduce everything for from 1 to 10 billion scale, the Alpha Centauri would be 2,500 miles. So the Milky Way galaxy has about 100 billion stars. Now, how big is the Milky Way? If you have time, if you just like to put some thoughts into it, just calculate how big is the Milky Way. You can find this information on the Google as well. Now let me ask you a question. If you can count one number or one star per second, and then if I ask you to calculate how many stars or how long it take for you to count 100 billion stars. In our galaxy, we have about 100 billion stars. And if you have to count one by one, how long would it take? If you come up with a number, if you just do a little math, you will find it out. It takes about few thousand years to calculate the entire, to just to count the 100 billion stars. It takes few thousand years. If you're calculating non-stop, one star in 1 second, or in 1 minute, if you're calculating 60 stars, then just to calculate, or just to count the total stars in our galaxy, it takes about few thousand years. So it's a big number. So how big is the universe? It's quite big. How many stars we have? What's the 100 billion galaxies look like? If I just give you 100 billion galaxies, what's the perspective? So if you go to the beach and you see the sand, the particles, or the grains of the sand, and over the entire earth, if you calculate over the entire earth, if you count all the sand grains, that's how many stars we have in our Milky Way galaxy. You see, over the entire earth, all the beaches, if you count out it's the grain, that's how many the galaxies, the stars. So we have 100. If you just count, it takes about, oh, excuse me. So we have about 10 to the 22 stars in our Milky Way galaxy, which is equivalent to all the sand grains on all the beaches on the earth. So what we learned so far now, the thing we learned is how big is the universe. And just to put the numbers for the universe, is very challenging. Just to give you a perspective, if we reduce the size from 1 to 10 billion scale, the Earth is the size of a ballpoint, which is 15 meters away from the Sun. On the same scale, the stars are thousands of kilometers away. So if we are 15 meters away, the stars are thousands kilometers away, and it would take more than 3,000 years to count the stars in the Milky Way galaxy if you count one in 1 second. The observable universe is 14 billion light years in radius, and which contains 100 billion galaxies. And, and if you count the total number of stars within the 100 billion galaxies, which is equivalent to all the grains of sand on the Earth's beaches. Now we'll talk a little bit about the history of the universe. Okay, first thing we'll talk about the cosmic calendar. What is a cosmic calendar? It's a very interesting terminology, the cosmic calendars. So the cosmic calendar is a scale in which the 14 billion year lifetime of the universe, 14 billion year lifetime of the universe. The universe lifetime is 14 billion year, and this entire lifetime is mapped into a single year. That's what we call the cosmic calendar. So this image helps to put out the cosmology, evolution, and written history in the context. At this scale, on the cosmic scale, on the cosmic calendar, the Big Bang, the birth of the universe, took place on the 1st January at midnight, and the current time is mapped to the December 31st at midnight. So we're starting from January 1 midnight, and the end is December 31st at midnight. At this scale, if we just divide the 1 year, the 14 billion year into 1 year, 14 billion year into 1 year, there are 434 years per second. Each second corresponds to 434 years. Each second, let's say on a cosmic calendar, if each year passes, that means it is equivalent to 434 years. And 1 hour means 1.57 million years. And the 1 year is 38 million years, just on a cosmic calendar. So this is not pretty clear here. So the one day, just from Sunday to Monday, that means about 38 million years has passed. And this concept, the cosmic calendar, was very popularized by Carl Sagan in his book. So again, if we dig further, on a cosmic calendar which compresses the history of the entire universe, the lifetime of the universe, into 1 year, human civilization is just a few seconds old. And a human lifetime is a fraction of a second. So if you just take a calendar, this calendar, if that calendar represents the age of the universe, we are just a fraction of a second. In each second, many lives, many generations have passed. Now we'll talk about the spaceship Earth. So in this case, we'll learn how do galaxies move within the universe, how is Earth moves through the space. So this is our Earth here, and the Earth rotates about its axis, as well as it also orbits around the sun. And the entire solar system also rotates about the galaxy. You see the motion here. Earth has its own motion. Then the Earth also rotates about the sun. Other planets also rotate about the sun. And the entire solar system rotates about the galaxy. Are we sitting stationary? No. We have the motion. For example, the Earth is orbiting, is rotating, and the Earth is rotating about its axis. So if you see, and it does have the same angular speed, but if you are on the equator, the Earth's the velocity, the tangential velocity that you have is 1670 kilometer per hour. And as you go up or down, as you go towards North Pole or the South Pole, the speed starts decreasing. And at the Earth, you see, like we are at the United States right here, or about the border of the Canada and the United States, and the tangential velocity we have is 1100 kilometer per hour. And in Australia it is the same thing, it's about 1100 kilometer per hour. So the tangential velocity is different at the different locations of the Earth. If you are right on the North Pole or the South Pole, you're not moving compared to the compared to the let's say, because everything is moving, but the tangential velocity starts decreasing as you go from equator to the north. Okay, and just to give you perspective, this is 17 kilometer per hour. The jet plane moves has a speed about 900 kilometer per hour. So we are moving even much faster than the jet plane. So the astronomical unit is the average distance between the Earth and the Sun, which is about 115 million kilometers. And the Earth axis is tilted about 23.5 degree. If you look from the top, if you look or from the North Pole, it rotates counterclockwise. You see here. Now, this is the solar system, the galaxy, the Milky Way galaxy. And the solar system is right there. The sun is a tiny speck. And it takes about 230 million years for the solar system to complete one orbit around the, the Milky Way galaxy. And the speed at which it is moving is about 800,000 kilometers per hour. It's 800,000. So this entire solar system moves around the Milky Way galaxy about 800,000 kilometers per hour. Everything is moving. It's so fast. So, what we learned here? We learned that the Earth rotates about its axis, and it takes 365 days to complete one complete rotation around the Earth. Stars in the local neighborhood move randomly related to one another and orbit the center of Milky Way in about 230 million years. So that's it. If you have any question, please feel free to write me. Thank you so much.